Welcome to this lesson on EC2 Instance Types, choosing the right size. This is part of our AWS Compute series. In this video, you'll learn about the different instance families available in Amazon EC2 and understand how to select the right instance type for your specific workloads. So what exactly are instance types? Instance types are essentially configurations of CPU, memory, storage, and networking capacity for your EC2 instances. Think of them as different computer specifications tailored for specific needs. These configurations are grouped into families based on their performance characteristics, and each family is optimized for different types of workloads. The pricing for these instance types varies depending on the resources and capabilities they provide. AWS organizes instance types into 5 main categories. First, we have general-purpose instances, which provide a balanced mix of compute, memory, and networking resources. Second is compute-optimized, featuring high-performance processors. Third, memory-optimized instances offer fast performance for processing large datasets in memory. Fourth, storage-optimized instances provide high sequential read and write access to data. And finally, accelerated computing instances come with hardware accelerators like GPS and FPGAs for specialized tasks. Let's dive into general-purpose instances. These include the T series, which are burstable, and the M series, which offer balanced performance. They provide a balanced ratio of compute, memory, and networking resources, making them versatile for many applications. Common use cases include web servers and application servers, small to medium databases, and development and test environments. If you're just starting out or have workloads with moderate and consistent resource needs, general-purpose instances are often the best choice. Next, we have compute-optimized instances, primarily the C series. These instances feature high-performance processors and deliver the highest compute performance per dollar on AWS. They're ideal for compute-intensive workloads. Common use cases include batch processing and high-performance computing tasks, gaming servers and simulation workloads, and machine learning inference along with scientific modeling. Choose these when your application requires significant CPU power, but doesn't need as much memory or storage. Memory-optimized instances include the R series for RAM-intensive workloads and the X series for extreme memory requirements. These instances deliver fast performance for workloads that process large datasets in memory. They're perfect for high-performance databases and in memory caches like Redis or Memcached, real-time big data analytics and processing, and enterprise applications like SAP HANA. If your application keeps large amounts of data in memory for fast access, memory-optimized instances are your best bet. Storage-optimized instances come in 2 main series, the I series for I/O intensive operations and the D series for dense storage needs. These provide high sequential read and write access to very large datasets on local storage. Common use cases include NoSQL databases like Cassandra and MongoDB, data warehousing and distributed file systems, and high-frequency online transaction processing. Choose these when your workload requires extremely fast access to large amounts of local storage. Accelerated computing instances include the P series for GPU computing and the G series for graphics-intensive applications. These instances come with hardware accelerators like GPS and FPGA as to perform floating-point calculations and graphics processing much faster than software running on CPS alone. They're ideal for machine learning training and deep learning, video encoding and graphics rendering, and computational fluid dynamics and seismic analysis. If your workload benefits from parallel processing or graphics acceleration, these instances are essential. Understanding instance naming is crucial. An instance name like M5.2x large follows a specific pattern. The first letter, M, represents the instance family. The number 5 indicates the generation, with higher numbers being newer. The last part, 2x large, specifies the size. Sizes progress from nano and micro for the smallest, through small, medium, and large, then X large, 2X large, 4X large, and continue scaling up to metal instances, which provide direct access to the physical server. When choosing the right instance type, consider 4 key factors. First, understand your workload requirements by identifying your CPU, memory, storage, and network needs. Second, analyze performance metrics by monitoring your current application behavior and identifying any bottlenecks. Third, balance your budget constraints with performance requirements to optimize costs. Finally, consider your scalability needs by thinking about growth patterns and traffic variations. Getting this right ensures your applications run efficiently without overspending. Here are 3 key considerations to remember. First, always match workload patterns by choosing instance families that align with your application's resource demands. Second, start small and scale up. Begin with smaller instance sizes, monitor performance, and upgrade only when necessary. Third, optimize for cost by using reserved instances or savings plans for predictable workloads to save significantly. Remember, right-sizing your instances ensures optimal performance and cost efficiency. Thank you for watching, and see you in the next lesson.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.